Hello, I should have started with this earlier presentation which I had made very old it is. The issue being saying why do we need to learn anything about this mechanical engineering. So, please follow this thing and so on. One of the first thing you will notice is that there is a significant and real difference between industrial design, that is all where this you get all your beautiful things which are available, and so called designer products, anything you come about right from clothes to standard items and all those interesting very extremely interesting products come from industrial design. And then secondly, designing for manufacturing, and design for manufacturing in mechanical it has become two types, which we will see in the subsequent slides. Any design in fact is a beehive of activity. Peculiarly we see that there are small cells, and we have this ultimate thing saying each cell is separate. The reality is all of them, the purpose is same. Purpose is saying we all work towards a product like this. If you see a complicated product like this, only core electronics forms the very important thing. I am not saying anybody can make it, core electronics makes the important thing. What does make the difference between a product that can be marketed and you can make profit out of it is the design of or presentation of the whole thing. So, here we come into the important, more and more important saying, is this a hornet's nest or is it a beehive of activity? Very important thing we talk about, saying there are so many things like that. Actually the small design comes here. Probably the starting point of any of these things is profitability and financial decisions, then the marketing and product management. So, these things follow, then we come to product management and eventually come into the small core issue about it. It depends on, for convenience I have just shown them about equal. If you are a marketing person, you will things important, and then all the time this new device technologies are coming about. That is how you are able to afford various other things. And most important is what our lecture is going to be is about CAD technology and computer assisted engineering tools. In the case of manufacturing for the printed circuit boards and all that, we have the EDA tools. EDA tools help in laying out the equipment, making a 100% analysis, and in the end you get things which will work every time under the given circumstances. Similarly, it is for the mechanical items. Even in the case of mechanical items, if you see here, everything else which is not electronic is probably covered under computer aided manufacturing, materials, and so many of these things. So, at leisure you can stop this. I will go a little closer, which does make a direct impact on us once you start the product design, is that all the time we have new CAD techniques. This CAD could be analytical, or the CAD could be laying out, CAD could be mechanical and so on. And now we have this CAM also associated with it. CAM is you have to directly whatever the designer wanted, he makes a file, and with minimum amount of confusion and having to get back to the source should be able to produce the equipment. So, the whole lecture so far what I have covered was about saying how to make certain files, certain things which are related to basic very core electronic design, which involves little bit of laying out of the equipment, and towards the end how to actually go to the workshop, find things how to do yourself, and in the end the files that you have created can be used by this CAD people, and it can be used for fantastic analysis, and finally automatic test equipment. So, these days in fact components are no longer, you do not bend a lead and put it into a PCB with the holes. Surface mount has come, and surface mount also these days one does not talk about how many components to mount and all that. What is talked about is it is a component shooter, how many shots per minute per second and so on. So, if you have a chance, you can go to look for any of the YouTube tubes on what is a component shooter which is used for making PCBs, but that is a lot more related to the other things. Now, we have come back to our very close, we are sort of converging back to our main thing, important things we need to concentrate whether you like it or not, and whether you are familiar with it or not, is manufacturability. What is the fabrication, what is the quality, cost and finishing, what makes things good, and maintainability, how do you assemble, how do you install. And our interest is these are not single use things. We are coming back to saying long term, how do you like to use it, and you as a designer, I am sure you are very very curious as to how some of the things have been lasting very long and are now our biggest manufacturing what you call setup in the world is able to make things dirt cheap versus things, even your costly mobiles are all made in China, same thing as the cheapest clone mobiles also. So, we have all this assembly, and all of us, whether you like it or not, we are here. Industrial design is what that makes actually integrates all these things together. So, I am not belittling or anything, I am just showing you that the thing called this feature integration of all the features, and a trade off, the designer has to take the trade off. At an extreme level, I do not like this torn clothes which people are wearing, but that is my personal thing, but obviously people pay good money to buy them, and we also have designer things and probably an occasional failure, but that is part of showbiz. Most important is we have this user satisfaction. User satisfaction involves ergonomics, aesthetics, and how well it is used, how well it can be used. Now, this is where we slowly come into what we can contribute is these things. Next picture shows you we have the environmental effects, then we have the interconnection effects, next we have the thermal effects. The moment you talk about any small prototype or anything, you end up with these things. You have seen that, no? Something you have to do such that something has to be closed, still heat has to be transferred across, but dust cannot come inside. Same thing about it, inside everything should be closed, but should you drop something into your bathtub or water splash on it, nothing should happen. So, we slowly come across fantastic equipment like this. You have seen this? It is a beautiful some device, I can't say what it is an equipment. My interest was saying the way it has been packaged, nothing will happen to it, it is deadly waterproof. And long ago we only used to have environmental standards for military applications. So, you have operating temperature from 0 to generally in our places 60, but minus 30 and all is normal. So, then we have humidity, then we have sand and dust IP67, then you have water, then you have drop test, vibration and altitude test. These once upon a time were only used for professional equipment, but these days even a small mobile, or in my case a hearing aid or your watch or your fitness tracker, all these things are expected to work at all these places. So, this, if some of you may remember this old Nokia, one of the earlier phones. Now we come to the very peculiar thing, saying, is it real or is it just a rendering on a computer screen? It is probably just a rendering, but I managed to pick it up. You see here clearly you have various stages of it. Finally you have the enclosure. Now to make somebody understand this, you need to probably make a very simple prototype. This is one of the earlier devices cut open, rather broken open. So you see here you have various things. So yourself can pause it and see various things here, and it is a wonder that things work the way how complicated it. And then we have from the mechanical side we have all these things. I was just trying to show you, saying this is inside a computer. I do not know whether actually it is a game, what do you call, high pressure, high performance gaming device or an ordinary device. But what we see here is, can you see here, we have very complicated things called heat pipes. All this is real. Now comes to the important thing which I wanted to tell you, where you will be able to make a difference. The thing is, a team approach is preferred over a sequential passing or over the wall. Preferred process allows early involvement by all key parties, moves issued like shielding and so on. This is made for something else, but I thought it will help in understanding. So, your earliest prototype probably you have to get across to your friends in the other parts of the team. So, my earliest lecture starting from the second or third lecture was about just to make, how to make something very easily at your computer. I still stick to that, saying it is easy, saying on where the resources have to be concentrated by the other people. And we have several standardizations also. This particular thing is called a single euro card, and it is a very old thing. Will you believe this? This thing was made about maybe 20 or 25 years back. So, it is, you need to make all these things finally to make these things work. So, we have a really beautiful way. Now, we come to this, saying your simple desktop or laptop solid modeling is available. So, various things like lofting and as I said, sweeping surfaces. I do not know whether it is from SolidWorks, Solid Edge, or any of the innumerable other model makers are there. The way photorealistic rendering has been made, it looks extremely real. So, this is where somebody needs to include all these things here, saying at in the beginning itself, if you take a stand on these things, typically you see product differentiation. So, if something can be made at a lower price, probably sales will be much better. So, we have here product differentiation for each market segment. So, that is where that marketing comes. So, in case your team is interested in knowing, you can always show these things to somebody, and you can do it yourself, saying, you see, this small product is meant for this application, and old people also need phones, but then keys should be different, should be tactile feedback, and you probably do not need so many features, but inside core can be same, basic core processor can be same, and you can continue to make products for different markets. And you see here fantastic build up is shown here, saying some are various types of solids. Now, this whole thing can be done by 3D printing, but it is just a concern of a concept. So, the end result is you have CAD files and tremendous amount of documentation which in the initial stage when we started it, it just started as a cardboard model made at home. Eventually, it can be verified, these CAD files can be verified after evaluation. So, I have started with you with a very simple way of how to start these things. These are all, you could have seen it in the beginning saying, at one instant what is a product meant to be used to resolve one or more issues during product development, that is what a prototype is. Yes, in that end the main issue seems to be newness everywhere, no? New design and one or more dimensions. This is what the engineering people will believe. The advantage for you is, instead of going around for a very comprehensive, very big prototype, it is much easier for you to come out with a very simple model and pass it along to all your team members, and probably one Friday meeting, if your product looks interesting and people are all focused, you are ready saying now we will work on these lines. So, now the next slide we are going to show you about mathematical construction. That is the word solid modeling we are talking about. Not full scale or analytical, just a model. Prototype means a full scale and physical. So, we keep all this type of thing, design of experiments, beta, pilot production and so on, this, you have seen this, no? So, right now at the time of going to this press, I am sure you also have got this thing saying they are going to release or already released dark mode WhatsApp. So, and the small print is only for beta users and you cannot access the beta user if you are already not a beta user. So, the everything you actually have to mass manufacture, you have to make a prototype, and then we have a simple proof of concept models and all the way to full fledged scalable prototype model. So, you see here I do not know what it is actually, but just I expect it is something to do with I do not know, some optical thing, maybe it is part of a spectrometer. The next few pictures show us what it is. You have seen that? This is taken from another thing, do not worry about it, saying at the extreme left we have all these things, and you see here now you know what it is. It is a projector which is taking full RGB and projecting onto the screen. That time these were not known very well. As in this we have a something here, then we have a prototype, and finally we have beautiful working units. To me it looks like a film projector. So, let me leave it there. Yes, it is a film projector. You see here you have something moving there, probably you load it and nicely the projector is working, and you see here we have solid modeling. And in this case of the solid modeling, this if you see is predominantly electromechanical. See this very predominantly electromechanical device. This electromechanical device probably has core electronics things, maybe 10%, 90% is all the enclosure. In our case it is the other way. So, a lot of these things are included, which I will just skip through, we do not need to. I think all of you know about it, no? I do not know how to pronounce it, but I will just call it a derailleur. Derailleur means it something changes your gears. So, we have a derailleur and then final prototype. Eventually, you have beautiful equipments like this, recumbent tricycles, So, we have all these things. This again is from the very interesting book which I have shown you, Ulrich and Eppinger. Get a chance, read the book and pay for it, so that it will be more valuable and people will try to steal. You do not steal. The advantage being, do you have a comprehensive, meaning all aspects included in it, or do you have to have a focus thing, or do you have a full physical or just analytical? Focused analytical is probably one type of FEM analysis like that. Physical comprehensive is a regular full fledged prototype here. So, this is full, okay. This is just math. So, we have all this alpha, beta, and then we have models and various things about it, how point of sale and so on, and all this is various things are there, which fortunately we do not know to. In my initial course you do not need it. You need to build a prototype, you need to uncover all these things, something about you can't calculate, learn from analytical, how people react to the device and so on. Now, at this point, this is where I kept telling you where our simple CAD modeling will help. I will just make a simple cardboard model, and all it needs is, I am sure, after a good night's lack of sleep, you can come out with multiple things. If you sleep, you are likely to forget. Just stay awake and make 2 different models, and I am sure you will be able to make things. So, all this stuff exactly, you have seen that. The art of prototyping is get the information you need at the least cost in time and money. You need to build early enough to understand. See, everywhere, every person, and this particular thing says design that matters, early. Not just early in the day, but early in the design cycle. Early in the design cycle, if you start these things, you will have very good chance of final product will meet the specs. So, let us say I will just take in our case only 2 types of people. One is the electronics people who do the various types of layout and coding and all that. Another type is the mechanical or the production people and the design people. In this particular case, I will use the design for the mechanical design and integration people. So, both of them, if they make their own variations and bring it to the table, and I am sure all it needs is one Friday meeting, by Monday you are full action. So, we have concept prototype and so on, understand the physics and phenomenal involved, same thing. This is in our case will be electronics. So, if somebody can talk about it, most of the time if you see our mobile phone started with that good old Nokia, and good old Nokia did not even have a headphone socket, I understand, but the one that sold in India had a LED lamp, and that made sure that nobody had to carry a separate torch, and you could speak on the phone. So on slowly FM radio started, and the moment the FM radio started, we ended up with the wire and antenna and the headphones, and you will not disturb anybody if you want to listen to your own music. And now a phone like this is probably ancient. I have just used a gag sticker to make it look like a camera. The reality is, unless something has at least one wide camera to drop the background and one focused 20 megapixel camera, and then probably a range of sensors here, and same thing in the front, saying a smartphone will be considered dumb if it does not have a camera. The fallout is that the small cameras people have stopped carrying it along. Everybody has one, that is a separate problem, and you have a beautifully featured this thing. So, looking back at this, you see here no beautiful amount of combinations of things have been given. This what I kept showing even my earlier thing, catalogs information is generally authentic, and these days it is becoming expensive to have catalogs, but so most websites which give you the equipment or equip all the subsystems, give all of these things to you without any problem. You can get all the equipment you want, get all the subsystems you want, get details of each of them including a connector and including everything, and finally this is from the mechanical point of view, so ignore it. This is then a full fledged prototype is going to probably cost you 100 times 100 is still a lot of money. So, that if you need to sell this for, let us say, I think when we bought it was around 15,000 rupees. So, it will probably cost you to make a device like this now, it would have costed them a lot of money to make full. That is, you have a case, then you have all the necessary what do you call printed wiring boards, and you have a display, everything, The first few models would have cost them maybe 10 lakhs each. Then finally, they have been able to, right now this is available for sale in India for about 5 or 6,000 rupees. This is an old Motorola, I do not know, E5 or E5 plus or something. So, if you look at very huge things like that here, or in the case of a ship, a cruise ship, that is the final thing. And you see all this, from the place where I have come, these are all very beautiful devices which are used for materials research. So, these are different, and then there you have seen that. So, we have all this which have been given here. So, you can go through it. Since a little old, I have shown you by somebody else's thing saying. So, we have all these things saying now stereolithography is there. So, you can just stop it here, see if you can. I had access to this. So, I was able to use it. Okay. My suggestion is you can go through this right now. I will stop the lecture. The focus in this has been saying why a prototype is required. You have got my point, no? The whole focus in this saying why do we need a prototype at all? Why can't we just go about building the whole things? I will continue this lecture afterwards, after a small break, to say our own experiences with these things. Okay. So, thank you. I will continue a little later.